Okay, let's look at this problem about lightning strikes. Alright, so this problem about lightning strikes, if we read through it, it tells us that the number of lightning strikes on a square kilometer in a year has mean 6, standard deviation of 2.4. So we can go ahead and come over here and write that information down. We know that mu for our situation is 6 and sigma is equal to 2.4. Alright, so it's useful to write that down right away. Okay, and it says that here's a thing, we do sensors, right, and we do these sensors and we get a sample of 10 1 kilometer plots. So n equals 10. Alright, so what are the sample mean and standard deviation of the sampling distribution of x bar, right? So x bar, right? X bar, right? We're asked about this distribution, and so we know mu sub x bar is simply going to be mu, which is 6, and we know sigma of x bar is going to be sigma divided by the square root of n, which is going to be 2.4 divided by the square root of 10. Okay, and if we put that into our calculator, you should get an answer of about 0.76. Okay, you can verify that if you wish. Here's your calculator. Let's get out of there, clear this out. 2.4 divided by the square root of 10. How about 0.76? Alright, we can see there. Okay, so that's part A. Okay, part B, explain why you cannot safely calculate the probability that x bar is less than 5 based on a sample size of 10. Alright, well, what do we know here? We know that we are not known if x is approximately normal, right? Well, if we don't know if x is approximately normal, therefore our sample size is too small to use the central limit theorem. N is not greater than or equal to 30 because n is only equal to 10. Okay. Suppose that our organization takes a random sample of n equals 50 square kilometers instead. Explain how the central limit theorem allows us to find the probability that the mean number of strikes per square kilometer is less than 5, and then calculate. Okay. Well, for that portion, if I'm coming up with that portion, here's what I have. We know that if our sample size is greater than or equal to 30, then our sample distribution of sample means is approximately normal with some mu sub x bar and sigma x bar. Okay, that's what the central limit tells us. The central limit theorem tells us. Therefore, for this situation, x bar is approximately normal in here with the mu of 6 and a standard deviation of 2.4 divided by the square root of 50. Right? Why the square root of 50? Well, the square root of 50 is because our sample size is 50. Okay? And we're looking for the probability that x bar is less than 5, which would be the same as the probability that z is less than negative 2.95. Okay. Now, how did we get that z value? We know that z is equal to our statistic minus our parameter all over our standard error, and our standard error here is 2.4 divided by the square root of 50. Right. We can verify that information on our calculadora. Right. Turn our calculator on. 5 minus 6, there's that number, divided by 2.4 over the square root of 50. Right, there's your negative 2.95. Right, pretty straightforward. Okay. Now, if I use my table or my calculator, I find this probability is 0.0016. So therefore, we are very unlikely to have a sample mean from a sample of size 50 have number of lightning strikes be less than 5. Okay. For this material, you can always check the problems from the book that are odd in the back of the book. So I will only be doing the